In this guide, why public OAuth clients and wallet apps need something stronger than a static client secret. How a client attester signs a client attestation JWT that is bound to the app instance's own key. What the headers, challenge endpoint, and token request look like on the wire. And the replay, privacy, and platform security trade-offs this draft is designed to solve. Identity Expert, powering you to be an expert in identity. Today we're unpacking OAuth 2 Client Attestation, formerly called Attestation-Based Client Authentication. This is the draft that tries to solve a long-standing OAuth problem. How does a native app, wallet, or other public client authenticate itself without embedding a client secret that every attacker can extract? The answer is not a password. It is an attester-signed JWT bound to a key generated on the device itself. The app presents that attestation plus proof that it still holds the private key. The authorization server authenticates the client instance, not just the software name. Think of it like entering a secure building with a company-issued badge. A normal OAuth public client is like showing up with only a printed app name on your shirt. Anyone can copy it. Client attestation is the badge. A trusted issuer signs it and says this badge belongs to a genuine employee device. But the guard does not stop there. The guard also asks you to tap the smart chip in the badge, proving you still hold the private key bound to that badge. A photocopy of the badge is useless. The signature says who vouched for you. The proof of possession says the badge is really yours right now. There are 4 concrete problems this draft is trying to fix. First, public clients cannot safely hold a static client secret. Mobile apps, browser code, and wallet apps are all reversible. Second, traditional backend-mediated client authentication creates privacy leakage. In issuer-holder verifier ecosystems, a backend that authenticates the wallet can observe which authorization server or issuer the user is talking to. Third, platform trust signals are fragmented. Apple App Attest, Android Play Integrity, Android Key Attestation, and device-bound secure enclave keys all exist, but every authorization server would otherwise need bespoke logic for each platform. Fourth, sender constraining the attestation itself matters. If the attestation is not bound to a client-generated key and refreshed with a fresh proof, replay is trivial. Client attestation gives OAuth a common wire format for all 4 problems. The flow has 4 main moves. First, the client instance generates its own asymmetric key pair on the device and sends the public key plus platform evidence to a client attester. That attester might be the app vendor backend, or in some deployments the client itself. Second, the attester validates the evidence and returns a signed client attestation JWT. That JWT contains the OAuth client identifier in sub, an expiry time in exp, and the client instance public key inside the cnf.jwk claim. Third, before using the attestation, the client may fetch a server challenge from the authorization server's challenge endpoint. Fourth, the client sends the attestation to the token endpoint along with a proof signed by the instance key. That proof can be the draft's own Client Attestation-PoP JWT, or DPoP, if the server supports attest_JWT_client_auth_DPoP. On the wire, 3 artifacts matter. First is the Client Attestation JWT. Its header type is OAuth-Client-Attestation plus JWT. Its payload carries sub for the cliented, exp for expiry, and cnf.jwk for the client instance public key. Second is the optional challenge flow. The client posts to the challenge endpoint advertised in authorization server metadata and receives an attestation challenge value plus an expires in lifetime. Third is the actual token request. The request uses the OAuth-Client-Attestation header for the attestation, the OAuth-Client-Attestation-PoP header for the proof JWT, and the normal OAuth form body for grant type, code, redirect URI, cliented, or whatever grant is in use. The proof JWT carries auth for the authorization server, JTI for replay detection, IET, and optionally challenge. The draft shifts the threat model rather than eliminating it. 3 risks dominate. First is replay. An attacker who captures an old proof JWT or reuses a long-lived attestation can try to authenticate later. The defenses are short attestation lifetimes, JTI tracking, IET freshness windows, and server-provided challenges. Second is cloned or repackaged clients. If the client attester accepts weak platform evidence, a malicious app can obtain a perfectly valid attestation and look genuine to the authorization server. The real root of trust is the attester's verification policy, not the OAuth header itself. Third is privacy correlation. If the same device key or stable claims are reused across authorization servers, the attestation becomes a tracking handle. Pairwise keys, minimized claims, and audience-specific freshness policies reduce that risk. The strongest deployments combine challenge-based freshness with hardware-backed keys and aggressive attestation rotation. 4 trends are pushing this draft forward. First, the draft itself is maturing inside the OAuth working group, with registered headers, a challenge endpoint, and two token endpoint auth method names now defined. Second, DPoP is the key compatibility story. Because RFC 9449 is already deployed, the draft can reuse DPoP as the proof layer instead of inventing an entirely separate deployment stack. Third, wallet ecosystems are the biggest adoption engine. OpenID for verifiable credential issuance and the EUDI wallet architecture both need a way to prove that a requesting wallet is genuine software on a real device with hardware-backed keys. Fourth, public client hardening is becoming the default direction for OAuth overall. PKCE, sender-constrained tokens, attestation, and device-bound keys all point the same way. Stop treating mobile and browser software as anonymous just because they cannot hold a shared secret. All primary sources cited in today's guide are listed on screen. You'll find direct links to the draft, RFCs, and related wallet specifications in the video description below. If this breakdown helped you understand the topic better, please subscribe to Identity Expert. We publish a new protocol deep dive every week. Thanks for watching. If there's a specific identity standard, authentication flow, or security protocol you'd like us to cover next, drop it in the comments below. Subscribe and hit the bell so you never miss an episode.